Good morning, good afternoon, good evening, everybody. Welcome back. In this video, I want to conclude topic 8 by looking at what is topic 8.4, human population carrying capacity. Now, the good news here is, although this is an entire subtopic on its own, we've covered an awful lot of this already. So when we look at human population carrying capacity, you can see above my head, we're going to be looking at population growth, natural capital, ecological footprint, and environmental value systems. Now, all of those things we've pretty much covered before in previous videos. I also want to cover two theories of human population growth, which is Malthusian theory and Bohr's theory. I'm going to attempt what I imagine you thought was impossible for me in this video. When we look at stuff that we've already covered before, I'm going to try and include some clickable links on the YouTube clip so that you can click on them and go back to stuff we've covered already. All right, so let's start as usual by looking at the syllabus. It looks like an awful lot, but like I said, we've already covered a lot of this before. All right, so in terms of knowledge, first of all, a definition of carrying capacity. I'll give you another version of that in a second. This one says it's possible to estimate carrying capacity for a given species, but this may be problematic in the case of human populations. We'll look at why that's the case. Here it says, well, the next 3 points actually, I won't go into them because they're all about ecological footprint, and you can take a look at a previous video, the previous videos we've already done on ecological footprint. Then we can spend a little bit of time looking at how humans, well, it says resources here, how humans use natural capital, and how we can look at natural capital as being finite. So therefore, does that put a pressure on human population to reach a certain carrying capacity? We'll look at that. And then obviously the last one is just a point of fact. If human populations do not live sustainably, they will exceed carrying capacity and therefore risk collapse. In terms of applications, we need to evaluate the application of carrying capacity to local and global human populations. We need to compare and contrast the differences in ecological footprint between countries. I'll do that very briefly. And then finally, we need to evaluate how environmental value systems impact ecological footprint. Now, we have already looked at that before, so I will put a link so you can have a look at the previous work we've done on that. Okay, let's move rapidly on. Okay, the graph on the right-hand side here, we've seen that before. This is the carrying capacity graph for what we would call a K species. Now, again, I can put a link here so you can have a look at previous work we've looked at on this topic. So species that we call K species basically live on an S-shaped curve. That means the population has, as it starts from scratch, it has a exponential phase, and then it reaches a plateau phase where it plateaus off. In between, we've got something called a transition phase. When the population reaches its carrying capacity, it wobbles around the maximum value, and that wobble is caused by, as you know, negative feedback. If the population rises too high, negative feedback brings it down again. And if the population drops too low, negative feedback brings it back towards the carrying capacity, which we use the term K. Okay, so obviously, therefore, the definition of carrying capacity we can see here. Carrying capacity is the maximum number of individuals of a species that can be sustainably supported within a certain habitat. So you might think that's the end of it, but then we need to consider, does this apply to human populations? Well, the answer is maybe or maybe not. And then the other question, quite a fundamental question, do human populations therefore actually have a carrying capacity at all? And again, the answer is maybe or maybe not. So we need to kind of evaluate those questions. Okay, so first of all, for the first of those questions, for human population growth, For something like a rabbit population, which is a case species, like we looked at in that previous graph, the only thing that will the only thing that impacts really is how big the population is and how that impacts on natural capital. A rabbit can't choose, or a rabbit population can't choose to conserve its resources in order to help future generations of rabbits. They have no technology to rely on to change carrying capacity. So therefore, the only thing that affects the carrying capacity is the effect of the population on the resources they use. However, in human terms, we could consider, well, first of all, the amount of natural capital used depends on your wealth, which depends ostensibly on whether you're born into an MEDC or an LEDC. It depends on what you see as the natural capital you need and the natural capital you want to use. Those two might be very different things and very different depending on whether you're in an MEDC or an LEDC. Population growth also depends on the age distribution or the population pyramid of a specific country. And it also depends on whether that population is rural or urbanized. Consider also, approximately only 20% of the world's population lives in MEDCs, and generally in MEDCs, the crude birth rate is falling. However, approximately, again, 80% of the world's population lives in LEDCs, where we're still seeing a rise in birth rate. Okay, in terms of the second question, does a carrying capacity really exist? That's a very difficult question to answer, but it depends on a few things. Number one, it depends on the amount of waste we produce. Humans are the only species that produce non-biodegradable waste and therefore affect the habitat by the waste they produce. No other species produces non-biodegradable waste. I've kind of mentioned this already. The resources or natural capital we use, we can see them as necessities or luxuries. The luxury of somebody in an LEDC is very different to what somebody in an MEDC would also perceive as a luxury, presumably. Human populations, well, the only species that have the ability to move goods from one place in the world to another part of the world. We're able to actually import or export our natural capital. Well, I was going to say we're the only species that uses technology. It's not true that we're the only species that uses tools, but certainly our technology can't be compared to any other species on Earth. It has a big effect on carrying capacity. So some things to consider. I don't think I've really answered the question whether carrying capacity exists or not, but maybe the next two slides will help. Okay, this guy is called Thomas Malthus. He was a clergyman who lived 200 years ago, and he believed that human population will reach a crisis point at some point. And the reason for that was he correctly surmised that human population is rising exponentially, and possibly still is. But he also surmised that the availability of natural capital is not exponential, it's linear. And if that's the case, we reach a point where the human population exceeds the amount of natural capital that it needs. And he called this point the crisis point, or a bit more prosaically, the point of catastrophe. And he said that was the point at which human population is destined to collapse because it doesn't have the natural capital to support it. He got himself a reputation, fairly recently actually, of the original doomsayer, the person who said that humankind was doomed basically to extinction or close to extinction. And that wasn't really the case at all. He was just doing the maths. The thing he didn't actually perceive at the time was how human technology would change. That there would be great leaps in human technology that would make more and more natural capital available. We'll look at that in a second. And actually, possibly his greatest contribution to science was he was a huge influence on Charles Darwin. So Darwin read Malthus, and he specifically what he talked about overpopulation. And Darwin realized the effect that overpopulation of a species would have in terms of pushing natural selection, variation and natural selection. So possibly his biggest contribution to science was indirectly. Okay, that's Malthusian theory. This is Bohrup theory. This is Ester Bohr. She was an economist working in the 20th century, and she disagreed with Malthus effectively. She said that yes, human population increases exponentially, but natural capital is not linear. When humans need to, we use our technology to push upwards the amount of natural capital that we're able to exploit. In other words, nice little phrase, necessity is the mother of invention. When humans need to make more natural capital available through our technology, we do so. So basically, she's suggesting that natural capital will never cross the line of population, so therefore we don't reach this crisis point. The problem with her suggestion is that she's kind of moving towards the idea that therefore natural capital is infinite. But we know it's not infinite because we only have one planet. So there's an issue with her work as well. Some examples here of how we've made big leaps forward in improving the availability of natural capital. Could be land reclamation, selective breeding and genetic modification, very simple technologies like the terracing of land that makes land available for agriculture that wouldn't otherwise be available, hydroponics, growing plants without soil, other simple technologies like greenhouses, irrigation, the use of fertilizers, switching between crops that are better suited to different environments, and things like fish farming. Okay, so that's Malthusian theory and Bohrup theory, and the suggestion of how human population growth is linked to natural capital availability. That's as much as I want to do today, with one exception. Now, we did talk about ecological footprints at length previously, but we talked largely in terms of per capita ecological footprint. There's one sentence in the syllabus that I gave you before that said, if I can remember, we need to compare the environmental ecological footprint, of 2 different countries. Now, in order to enable you to do that, ecologists or environmentalists generally look at 6 components of a national footprint as opposed to a personal footprint. So if you want to compare 2 countries in terms of the EF, I think you should do it in terms of these things. Number 1, the footprint of built up land or urbanization in that country. Obviously, if you pave over your habitat, you're producing habitat destruction, but also cement especially produces huge amounts of carbon dioxide greenhouse gases. So it increases the footprint hugely. You should also consider that a national footprint doesn't end at the country's borders. In some cases, it extends into the sea, especially in terms of fishing grounds. So basically, the footprint can extend beyond national borders or land borders. You should consider the amount of forestry in that country. So that affects natural capital availability and also the absorption of waste. Footprint of grazing land, obviously. Footprint of agricultural land. And the amount of land available for carbon sequestration, which links back to the amount of forestry. Okay, now because it's quite a disjointed part of the syllabus, I think this video is quite disjointed. But my idea was just to give you a bit of food for thought so that we can discuss this further in our classes moving forward with the course. Okay, so any questions, please let me know. I'll speak to you this week anyway. And take care of your families, and speak to you soon. Okay, goodbye everybody.